Hello learners, in this lesson we are going to learn about sequences with cubic rule and how to find the end term of such sequences. By the way, what type of sequence is called a sequence with a cubic rule? There are sequences whereby the constant common difference go into the third order. Recall from our previous lesson where we discussed sequences with quadratic rule. We got the constant term from the second order difference. For sequences with cubic rule, for us to get the constant term, we need to take their differences into the third order. What do I mean? We have an example here, and the sequence is 11, 18, 37, 74, and 135, and so on and so forth. So to get a constant difference in this sequence, we need to take the differences up to the third order. Let's do that and let's see. We have 18, 37, 74, 134, 5 rather, and so on and so forth. Taking the first order difference, 18 minus 11 is 7, 37 minus 18 is 19, 74 minus 37 is 30, 37 is 7, and 135 minus 74 is 61. This is the first order difference. You can see that the differences are not the same. Now taking the second order difference, 19 minus 7 is 12, 37 minus 19 is 18, and 61 minus 37 is 24. Again, the second order difference is non-constant. Let's move to the third order difference. 18 minus 12 is 6, and 24 minus 18 is 6. Here, the third order difference. This is second here. This is third now. Order difference. You can see that here we have a constant common or a common difference. So any sequence whereby before you can get a constant difference, you must take the differences up to the third order level. Such a sequence is called a cubic sequence or sequence with cubic rule. Now, how can we get the nth term of such a sequence? The general formula for sequences with cubic rule is an to the power of 3, and this is exactly why they are called cubic rule. The highest power of n is 3. Unlike in our previous class where we looked at sequence with quadratic rule, the highest power of n is 2. And for linear sequence, the highest power of n is 1. So here, discussing about sequences with cubic rule, the highest power of n is 3. So Tn is equal to an cubed plus bn square plus cn plus d is the general formula for a sequence with cubic rule. So if you are given a particular cubic sequence, you can use this general rule to determine the nth term of that particular sequence. And I have some examples here from A down to D. The first one is 4, 14, 40, 88, 164, and so on and so forth. So how can we get an nth term for this very sequence. To do that, we will use the formula I earlier, where is it? This formula here, Tn is equal to an to the power of 3 plus bn to the power of 2 plus cn plus d. But before we do that, we need to take the difference, or the common difference of this very sequence. So the first one, we have 4, 14, 40, 88, 164, and so on and so forth. Taking the first order difference, 40 minus 4 is 10, 40 minus 14 is 26, 88 minus 40 is 48, 164 minus 88 is 76. That is the first order difference. Now for the second order difference, 26 minus 10 is 16. 48 minus 26 is 22. 76 minus 48 is 28. That is the second order difference. Taking the third order difference, 26 minus 16 is 6. Then 28 minus 22 is also 6. So we've got a common difference here, which is 6. And we got it from the third order difference because the sequence is a sequence with a cubic rule. Now for us to get the nth term of this very sequence, then we know that the general term for any cubic sequence is an to the power of 3 plus bn to the power of 2 plus cn plus d. Okay, using this, what if we substitute the value 1, 2, 3, 4, and 5 into this very equation here? We prepare another table like this, like we did in our previous lesson under sequence with quadratic rule. And if you have not gone through that lesson, I recommend you go through it because this is an extension of that lesson. So if n is equal to 1 here, when n is 1, if we put 1 into this very equation here, we have a plus b plus c plus d. What I did here is to put 1 into, use it to replace n in this equation. When n is 1, 1 to the power of 3 is 1. 1 times a is a. And when n is 2, still the same one rather, 1 to the power of 2 is still 1 times b is b. Then 1 times c is c. And then this d. I brought it down there. What about when n is 2? If I put 2 into this equation, 2 to the power of 3 is 8. 8 times a is 8a. Plus 2 to the power of 2 is 4 times b is 4b. Plus 2 times c is 2c. And then plus d. That is when n is equal to 2. When n is equal to 3, if we put in 3 here, 3 to the power of 3 is 27. 27 times a is 27a. Plus 3 to the power of 2 is 9. 9 times b is 9b. Plus 3 times c is 3c. Plus d. Okay, that is when n is equal to 3. Now when n is 4, put in 4 here. 4 to the power of 3 is 64. And 4 times 4 times 4. 64. A plus 4 to the power of 2 is 16. That's 16b. Plus 4 times C is 4C plus D. And then I have up to how many terms in this sequence? Let me prepare that table according to the number of terms I have here. 1, 2, 3, 4, 5. Okay, let's work for. We can stop there, but because I have up to 5 terms there, let me have up to 5 terms here too. So when n is equal to 5, if we put in 5 here, 5 to the power of 3 is 125, and 125 times a is 125a, plus 5 to the power of 2 is 25. I said 125 and I wrote 12 here. Now like longer, it's supposed to be 125a plus 25b plus 5c plus d. Okay, this is a table of the terms. Now, just like we took their differences there, we'll do the same thing. If I subtract this from this, d minus d is gone. 2c minus c is 1c. Or let me start from the first term. 8a minus a is 7a plus 4b minus b is 3b, and 2c minus c is c. D minus d is gone, 0. Again, we do the same thing here. 27 minus 8 is 19. 19a. 9b minus 4b is 5b. 3c minus 2c is 1c. D minus d gone, 0. 64 minus 64a rather, minus 27. That is 64 minus 27 is 37. Where's because okay, 37. 37a plus 16b minus 9b, 7b, and then 3c or 4c minus 3c is 1c. Okay, that is the second order difference. It'll be the first order. I still need one more. 125 minus 64. 125 minus 64. That is 61. We have 61a here. Plus 25 minus 16. 9b. Plus c. That is 5c minus 4c. Okay, that is the first order difference. Now taking the second order difference. This minus this, or 19 minus 7 is 12. 12a plus 5b minus 3b is 2b. Again, this and this. 37 minus 19. That is 18. 18a plus 7b minus 5b is 2b. C minus c is 0. Then taking the other difference again. 61 minus 37. Minus 37. 24. Have 24a plus to 24a plus 9b minus 7b, again 2b, 6c minus c is 0. That is a second order difference. Taking the third order difference. 18 minus 12 is 6a, 2b minus 2b is 0. Again, 24A minus 18A, 6A. Okay, so the third order difference is now constant, which is 6A, 6A. Now, if I call this first one here, if I call it table 1, and I call this table 2, let me call this table 2. Let me zoom out a bit so we can see table at a glance. Okay. Now comparing the elements of table 1 and 2, the last row in table 2 correspond to this. That means 6A is equal to 6. 6A is equal to 6. Dividing both sides by 6, we have A to be 1. That is that for A. Again, we compare this row here to this row here. That means, oh no, that is a wrong row. We're supposed to compare this to that. And let me undo that. Let me delete it altogether. This row here corresponds to this row here. In other words, 12A plus 2B corresponds to 16, and 18A plus 2B corresponds to 22. 24A plus 2B corresponds to 28. So we can equate any of that. That means, let me take the first one, 12A plus 2B is equal to 16. Solving for B, because we know the value of A, that means 12 times 1, which is the value of A, plus 2B is equal to 16. That means 2B is equal to 16 minus 12. Since 12 times 1 is 12. 12B, therefore, 2B rather, is equal to 16 minus 12 is 4. B, therefore, is 4 divided by 2, which is 2. So that is the value of B. Now, for us to get the value of C, we compare this row to this row here. The row correspond to each other. In other words, 7A plus 3B plus C is equal to 10. And 19A plus 5B plus C is equal to 26. 37A plus 7B plus C is equal to 48. And 61A plus 9B plus C is equal to 76. So let me take the first one, 7A plus 3B plus C. 7A plus 3B plus C is equal to 10. Equal to 10. We know A to be 1, so 7 times 1 plus 3 times, what is B? B is 2, plus C is equal to 10. That is 7 plus 6 plus C is equal to 10. 7 plus 6 is 13. 13 plus C is equal to 10. C, therefore, is 10 minus 13. 10 minus 13 is minus 3. That is the value of C. And the last one, to get the value of D, we compare this row now, which is the final row, this one, to the sequence itself. So A plus B plus C plus D is equal to 4. And then 8A plus 4B plus 2C plus D is equal to 14. 27A plus 9B plus 3C plus D is equal to 40, and so on and so forth. So let's take the first one, A plus B plus C plus D. A plus B plus C plus D is equal to what is number there? 4 is equal to 4. And what is A? A is 1, B is 2, so I have 1 plus 2 plus C is minus 3, okay, minus 3 plus D, which is what we're looking for, equal to 4. That means 2 plus 1 is 3. 3 minus 3 plus D is equal to 4. 3 minus 3 is 0. Therefore, D is equal to 4. And note that Tn is an to the power of 3 plus Bn to the power of 2 plus Cn plus D. We know A to be 1. 1 substituted here will be n to the power of 3. B is 2, so 2n to the power of 2. C is minus 3. Okay, let me remove this, supposed to be minus. That is minus 3n plus D. So the nth term of this very sequence is n cubed plus 2n squared plus minus 3n plus D. Let's put in n equal to 1, whether we'll get the first term of the sequence. The first term of the sequence is 4. So let's put in n equal to 1 here into this sequence, into this formula. If n is equal to 1, 1 to the power of 3 is 1, plus 2 times 1 to the power of 2 is still 1, minus 3 to the times 1, plus D, what is B? D is 4. Okay, that is 2 times 1 is 2 plus 1, 3, minus 3 times 1 is 3, plus 4, 3 minus 3, 0, 0 plus 4 is 4. Okay, it agrees with the first term. Let's check it with the second term, whether we'll get 14. So if n is equal to 2, putting in 2 here, that is n to the power of 3, that is 2 to the power of 3, plus 2 times 2 to the power of 2, minus 3 times 2, plus 4, which is D. Okay? I have 2 to the power of 3 is 8. 2 to the power of 2 is 4. 4 times 2 is 8 again, minus 3 times 2 is 6, plus 4. Now 8 plus 8 is 16. I have 16 there, minus, okay, let me add this 4 here, plus 4 minus 6, 16 plus 4, that is 20. 20 minus 6 is 14. Is that the term of the sequence? Yes, 14. That means our formula which is Tn equal to n to the power of 3 plus 2n squared minus 3n plus D is correct for that sequence. Okay, that is that for number 1. For number 2, I'm not going to repeat this table, so let me copy it and paste it somewhere so we can use it repeatedly. Let me delete all this 30 times 4. Let's select the whole table, copy it so you can use it repeatedly, because for any sequence with cubic rule, this table is the same. It's usually the same. Okay, let me zoom. Let's copy this and go down and paste it. paste it somewhere. Okay, that is a table. Let's go up and copy the question too. The question. Paste it here. Okay, so this is that. The second question is 423, 66, 145, and 272. Okay, let's get into that right away. So taking the first order difference, let me write the sequence first. 4, 23, 66, 145, and 272. So on and so forth. First order difference, 23 minus 4 is 19. 66 minus 23 is 43. 145 minus 66 is 79. Then 272 minus 145 is 127. That is the first order difference. The second order difference, 43 minus 19 is 24. 79 minus 43 is 36. 127 minus 79 is 48. That is the first order difference. Now the second order difference, sorry. The last order difference, which is the third one, 36 minus 12 is minus 24 is 12. Then 48 minus 36 is 12. Okay. Now if we compare this table here with this table here, the last row in this table corresponds to the last row in this table, which means 6a is equal to 12, which implies a is 12 divided by 6, which is 2. Now again, we compare this row now with this row. That means 12a plus 2b corresponds to 24. 18a plus 2b corresponds to 36. But 28a plus 2b corresponds to 48. Let's equate the first term from the row, that is 12a plus 2b equal to 24. 12a plus 2b equal to 24. And a is 2. That means 12 times 2 plus 2b is equal to 24. 24 plus 2b is equal to 24. 2b therefore is 24 minus 24. 2b is equal to 0. b is equal to 0 divided by 2, which is 0. To find c, we'll compare this row with this row here. That means 7a plus 3b plus c is equal to 19. 19a plus 5b plus c equal to 43. And 37 plus 7b plus c, 37a plus 7b plus c equal to 79, and so on and so forth. Again, comparing or equating the first terms of the row, 7a plus 3b plus c. Let me do that here. 7a plus 3b plus c equal to 19. And what is a? A is 2. That means 7 times 2 plus 3 times b is 0 plus c equal to 19. 14 plus 0 plus c is equal to 19. C therefore is 19 minus 14. C is equal to 5. To get the final value, which is D, we compare the first row here with the first row here, the sequence itself. So a plus b plus c plus d is equal to 4. 8a plus 4b plus 2c plus d is equal to 23, and so on and so forth. Let's take the first one in the rows. A plus b plus c plus d equal to 4. A plus b plus c plus d, do that here. A plus b plus c plus d is equal to 4. And a is 2. 2 plus b is 0 plus 5, which is c, plus d equal to 4. 2 plus 5 is 7. 7 plus d is equal to 4. D therefore is 4 minus 7, which is minus 3. And recall that the n term for any cubic sequence is 8n to the power of 3, bn to the power of 2, plus cn plus d. That means tn here will be a is 2 or so. Yes. So have 2n to the power of 3. B is 0. B is 0. So this term will be gone. And we'll move to the next one, which is C. C is 5. So plus 5 and plus 5 n rather. And D is okay, D is minus. So let me remove this plus here. Minus 3 is the n term of this sequence. Again, let's test the sequence or the formula for n equal to 1, whether we'll get 4 by putting 1 here. 1 to the power of 3 is 1. Let me even write it. I have 2 times 1 to the power of 3 plus 5 times 1 minus 3, which is 2 plus 5 minus 3. 2 plus 5 is 7. 7 minus 3 is 4. Does that agree with the first term of the sequence? Where is the sequence? Yes, the first term is 4. Let's check it for the second term to be 100% sure that our formula is correct. So n equal to 2. Putting 2 here, I'll have 2 times 2 to the power of 3 plus 5 times 2 minus 3. 2 to the power of 3 is 8. 8 times 2 is 16 plus 10 minus 3. 16 plus 10 is 26. 26 minus 3 is 23. Of course, that is the second term of that sequence, 23. That means our formula is Tn equal to an to the power of 3 plus 5n minus 3. This formula is correct. Okay, that is that for the second one. Again, for the third one, to avoid a repetition of this table, I'll copy it again. Let me copy that and move it down, because this table, whichever sequence we use it for, it's still the same table we are going to get, as long as the sequence is the sequence with cubic root. So instead of preparing the table over and over again, let's copy and reuse it. So paste it here. Let me use my mouse. Oh, that's different. This is the question I have to copy. Let's go back and copy. Copy the formula. Oh, sorry. Where's the table? Okay, here it is. Select it and copy it. Okay, so these are table. Now moving on to the third question, which is minus 1, 1, minus 5, minus 25, minus 65, and so on and so forth. Let's take the differences, starting with the first order difference. Let me write the sequence first. Minus 1, 1, minus 5, minus 25, minus 65. Again, taking the first order difference, I have 1 minus minus 1. Look at it. Where can I write that? 1 minus bracket minus 1. Minus minus is plus, so it will be 1 plus 1, which is 2. So here we have 2. Then this is minus 5 minus 1. That will be minus 6. Minus 25 minus minus 5. We write that here. Minus 25 minus, again minus 5. That is minus 25 plus 5, which is 20. So the difference here, minus 20, right? The difference here is minus 20. Okay, here I have minus 65 minus minus 25. That is minus 65 plus 25, which is minus 40. So here the difference is minus 40. That is that for the first order difference. For the second order difference, minus 6 minus 2. That is minus 8. Minus 20 minus minus 6. There's 2 levels of minus there. Minus 20 minus, then another minus again, 6, which is minus 20 plus 6. That is minus 14. Minus 14. And here is minus 20. That is minus 40 plus 20, which is minus 20. And let's take the last difference. Minus 14 plus 8 is minus 6. Minus 20 plus 14. Hope you understand what I'm doing. Look at this. Minus 14 minus minus 8. Minus minus is plus, so it's minus 14 plus 8, which is minus 6. Again, doing the same thing. Minus 20 minus minus 14. That is minus 20 plus 14, which is again minus 6. Yeah, minus 6. Okay, now comparing the tables, the first table, I'm calling this table, and this one table also. Let me clean this place here, because it's going to be useful for our work. Oh, okay, now if I compare this row here with this row, 6a is equal to minus 6. 6a is equal to minus 6. That means a is minus 6 over 6, which is minus 1. And comparing this row is 12a plus 2b is minus 8. 18a plus 2b is minus 14. 24a plus 2b is minus 20. Let's take the first one. 12a plus 2b. 12a plus 2b is equal to minus 8. And then a is already minus 1 here. So 12 times minus 1 plus 2b is equal to minus 8. 12 times minus 1 is minus 12 plus 2b equal to minus 8. 2b is equal to minus 8 plus 12. 2b is equal to 4. b equal to 4 divided by 2, which is 2. And to get the value of c, we compare this row with this row. So 7a plus 3b plus c is equal to 2. 19a plus 5b plus c is equal to minus 6, and so on and so forth. Let's take the first one. 7a plus 3b plus c. Let me do it there. 7a plus 3b plus c is equal to 2. And a is what? A is minus 1. Is 7 times minus 1 plus 3 times 2 plus c is equal to 2. 7 times minus 1 is minus 7. 3 times 2 is 6. And plus this c here equal to 2. Minus 7 plus 6 is minus 1 plus c equal to 2. C therefore is 2 plus 1. And minus crosses equality become plus. So c is equal to 3. And to get the value of d, which is the final variable we're looking for, we'll compare this row with this row. So a plus b plus c plus d equal to minus 1. 8a plus 4b plus 2c plus d equal to 1, and so on and so forth. Again, let me take the first one. A plus b plus c plus d equal to minus 1. Now a is minus 1. So minus 1 plus b is 2. C is 3. And d is what we are looking for. Everything equal to minus 1. Minus 1 plus 2 is 1. 1 plus 3 is 4. Is here 4. So 4 plus d is equal to minus 1. D therefore is minus 1 minus 4. This is plus 4. When it crosses equality, become minus. D is equal to minus 5. So we know the value of a, b, c, and d. Recall that the general term for any cubic sequence is a n to the power of 3 plus b n to the power of 2 plus c n plus d. A is minus 1. Now, if I put minus 1 there, how minus 1 times n is of course n. So minus n to the power of 3 plus b, which is 2 also here. 2n to the power of 2 plus c is 3. 3n. Then d is minus 5. Minus 5. This is the n term. Last question. We have 114, 65, 178, and so on and so forth. So let me write the sequence. I have 114, 65, 178, 377. Taking the first order difference, we have 14 minus 1 is 13. 65 minus 14 is 51. 178 minus 65 is 113. And 377 minus 178 is 199. That is the first order difference. Now the second order difference, 51 minus 13 is 38. 113 minus 51 is 62. 199 minus 113 is 86. Then the last difference, 62 minus 38 is 24. And 88 minus 62 is also 24. Let's compare this table here with this. So A or 6A correspond to 24. 6A is equal to 24. That means A is 24, divided by 6, which is 4. Again, to get the other variable, compare this row to 12a plus 2b correspond to 38, 18a plus 2b correspond to 62, and so on and so forth. Let's take the first one, 12a plus 2b equal to 38. 38, and a is 4, so 12 times 4 plus 2b is equal to 38. 12 times 4 is that is 48 plus 2b equal to 38. 2b therefore is 38 minus 48. 2b is equal to this minus this 0, 10. So b minus 10 is equal to minus 10 over 2, which is minus 5. And to get the value of c, we compare this row. Let me start here. Compare this row with this row here. 7a plus 3b plus c equal to 13. 7a plus 3b plus c equal to 13. Okay, and a is 4, so yes, so 7 times 4 plus 3 times minus 5 plus c equal to 13. 7 times 4 is 28. 3 times minus 5, that is minus 15, plus c equal to 13. 28 minus 15 is 13. 13 plus c equal to 13. That means c is 13 minus 13, which is 0. C is 0. And lastly, to get d, we compare this sequence itself with the first row of this table here. I have something like this. So a plus b plus c plus d is equal to 1. 8a plus 4a plus 2c plus d equal to 14. Let's do that. That sequence is supposed to be 1. But yes. A plus b plus c plus d equal to 1. A plus b plus c plus d equal to 1. A is 4. B is minus 5. C is 0. And D is what we are looking for. So 4 minus 5 plus D equal to 1. 4 minus 5 is minus 1 plus D equal to 1. That means D is equal to 1 plus 1. When this minus crosses it becomes plus. So D equal to 2. And recall that Tn is an to the power 3 plus bn to the power 2 plus cn plus d. A is 4, so 4n to the power 3. What is b? B is minus 5. B is minus 5. So minus 5n squared. C is 0, so the whole of this term is 0. While D is 2 plus 2. So the end term of this sequence is Tn equal to 4n cubed minus 5n squared plus 2. And that brings us to the end of this lesson. I hope you find it interesting. If you do, don't forget to hit the subscribe button and also destroy that like button too, so that you get more access when I release new videos.